Hello and good morning, everybody. Good to see you all. I'm pretty sure this will be Valentine's Day, so happy Valentine's Day to all you guys. Message from me to you. Okay, why are squirrels the best at Valentine's Day? Because they're nuts about each other. Ha ha ha. And they're always very sentimental. Sentimental. All right. Let's go straight into it. Today, we're going to learn about the trapezoidal rule. So if this comes up, hopefully, there we go. Trapezoidal rule. Basically, this is a way that we can find area under a curve, but it's used more in real life. It's more used in the field for areas that may not be easily represented by a nice function. Let's say it might not be a nice, what do you call it? Might not be a nice parabola, hyperbola. It might not be anything nice that we're familiar with integrating. It could just be a weird line, and we can still use the trapezoidal rule here. And it's an approximation method using the area of, you guessed it, trapeziums, trapezoids, these ones. You guys see that? Bit saucy. All right. Now, this is what it would look like to use the trapezoidal rule and why it's an approximation. So if we have, let's say, this kind of graph here, and we want to evaluate it between 1 and 5. Now, currently, what we would do is we would integrate it, right? But if we were to make this into the area of a trapezium, well, that's not what I wanted. Let's say, as gross as it is, what we could do is we could get pretty close. Of course, my dog would start barking. Pablo. Oh, buddy. Okay, so we'll use that as a trapezium, and that would approximate it. It would get us close, roughly into the ballpark. Now, what we've done here is we can kind of see that a function value, there's kind of key words that we use, and I'm going to define them for you. Can you guys hear that? Function value. A function value is basically, we talk about the number of x values. But if we talk about subintervals, then we're talking about the number of trapeziums we're dealing with. Okay. So just remember that as a basic rule of thumb. If they say function values, I'm looking for the number of x values that we use. And if we're talking about subintervals, I'm talking about how many different trapeziums we could use. So as an example, just so you can kind of see, at the moment, this would be, if we would deal with this big one here, and of course it turned into a triangle, but if we went with this big trapezium here, we would be working with 2 function values, because there's the 1 and the 5, but then we'll be working with 1 subinterval because it's 1 trapezium. Okay, now if I was to break it up a little bit more, and let's go with maybe yellow this time, I could break it up into, of course, this is going to be a good one today because it is Valentine's. So I could break this up into multiple smaller trapeziums. Now, in this case here, if we were looking at the yellow, we would say here that there is now 1, 2, 3, 4 subintervals because there's 4 trapeziums. But this time we'd be working with 1, 2, 3, 4, 5 function values. Okay, so that's kind of how this thing works. Just remember, subintervals, we're talking about the number of trapeziums. But if we're talking about function values, we're just talking about the number of x values that we've got. Okay, now here's what the formula looks like. Okay, the first one, I don't need to explain too much. If I'm integrating between a function between a and b, the approximation, now note here that we're using the approximation, is going to be b minus a. So there's the b, there's the a. The b minus a over 2 multiplied by fa plus fb. Or in other words, this is the same thing as height onto a plus b, or parallel lengths, right? The parallel sides. Parallel side 1 plus parallel side 2. Okay, now I'm not going to write this down officially, but that should be looking familiar. That there is the area of a parallel trapezium. Oh man, this is a shocker of a morning. Okay, so that would be the formula there. And I'll show you how to use both of these. Don't stress too much. Now, if we have multiple subintervals, so sometimes we'll use more than one trapezium, and there's a formula here that's not given to you, but it's helpful if you're dealing with more than one subinterval at a time. It looks like this. So H, the only thing you have to remember, H is the height of each trapezium. Okay. And if you want a formula for it, is H equals to B minus A over N, where N is the number of subintervals. All right. Now, once you have that, it's first and last plus 2 middle. And I'll show you how I kind of remember how that works. It's kind of like F of the first value plus F of the last value plus 2 of the Fs of everything in the middle. All right, all these Fs, F this. All right, now, okay. So now that we've kind of got that out of the way, let's actually show an example where we'll actually use this, right? So let's calculate the integration between 1 and 5 of 1x dx, 1 over x dx using the trapezoidal rule for one subinterval. So that means I'm just dealing with one trapezium. Okay, so that means here, I'm just going to write in blue. Simply put, this would be b minus a, which in this case is going to be 5 minus 1, all over 2. And then it's going to be multiplied by f of 1 plus f of 5. Okay, so in this case, that is 5 minus 1 is 4, 4 on 2 is just 2. And then f of 1 is, if I substitute 1 in, it's 1 over 1 plus 1 over 5. And that there should become my answer. 2 is going to be 12 and 5 units squared. Okay, I'm pretty sure that's it. That would be that. Now, that there is, because I'm only using one trapezium, it's not going to be as accurate as if I break it down. Now, if I'm using multiple function values, here's what I would do. What I would do is I would make a table of values. Okay, so if I was to fill out this table of values, using my function there, 1 on x, it'll be 1 on 1, which would just be 1. This would be 1 on 2, which would just be half, and so on and so forth. This would be a third, this would be a fourth, and this would be 1/5. Okay. Now, if you remember the formula, it goes a little bit something like this, and I'll use blue. The integration is going to become b minus a over n over 2, but I'm just going to write it as, what's the width of each trapezium? All right. The width is only going to be 1. So if I really wanted to, I know h equals to b minus a over n. So it's going to be 5 minus 1 over number of subintervals is 4 subintervals, because there's 1 subinterval here, 2 there, 3 there, 4 in between 4 and 5. So there's 4 subintervals, so it would be 2. And so my h would be, it'll end up being 2 over 2, which is just 1. Now, f of 1, so I'm going to put in this first value in here, right? First plus last, right? Plus 2 of everything else in between, a half plus a third plus a quarter. Okay, I'm going to move this up a little bit so it doesn't get too confusing. Yep. And that there becomes my answer. All right, which is going to be 1. Let's see if I can do this in my head. What's a nice common factor? 5, 2, 3, 4, 20, 60, probably 60. So it would be, oh man, 60. Oh, am I going to do this in my head? Someone in the calculator, see if you can beat me to it. I'm going to go with 60, 72 on 60 plus 2 times, okay, let's see, 30 plus 20, that's 50, 50 plus 15, 65 on 60. And this is going to end up becoming 72 on 60 plus 130, that's going to be 132.02 on 60, which is 101 over 30 units squared. But roughly, I think. Have I done this right? 72 plus 130. Yeah, sure. Sure, that's a little bit more accurate. Yep. And that would be your answer. So again, at this point here, just use your calculator. Don't try to do it in your head like I did. Now, there's a couple other things that I want to note that are helpful and that I've seen in HSC questions. They'll say, with this approximation, is it going to be more or less? Because it is an approximation, we can see that we're going to be a bit off. Now, remember, we're using trapeziums, right? So general rule of thumb is if I'm using the trapezoidal rule, when the curve is concave up, so it's kind of like on the smiley side, if you can see here, I'm going to take this whole area where really I only wanted the area under the curve, right? I only wanted this area here. So it's actually going to be an overestimation. So it actually overestimates when we're doing concave up. And of course, I would do this right during the video. And if it's concave down, the curve is concave down, you can see here that finding the area under this is actually going to underestimate. Underestimates the area under a curve. So hopefully that makes enough sense. And that gives you a little bit of an idea of how to go about the following exercise. If I was to break it down, even sometimes if they give you, and I'm going to add one more thing here that I didn't think of to do before, sometimes what they'll do is they'll give you some sort of weird curve like this. And what they'll give you is they'll give you some of the values. They'll say that's 0, they'll say that's 0. They'll say here that that's I'm just making things up as I go here. They'll say something like this is 5 meters, 5 meters, 5 meters, 5 meters. They'll say this is 20 meters, 18 meters, 12 meters. Or maybe 16 is more likely. Now, if I was to do the trapezoidal rule using this, remember, using multiple subintervals, it's going to be b minus a over n all over 2 multiplied by first plus last plus 2 middles. Okay, so in other words here, what I want you to think about this is that's h. So what's the height of each trapezium, right? We can see here that the height of each trapezium is just going to be 5. So in other words, this is going to become 5 over 2 multiplied by, what's the first value? It's 0 plus the last value, which is also 0. Now I'm looking here at that's 0, that's 0. And what I do now is I plus 2 lots of the middles, right? 2 lots of all the middles. So it's going to be 2 times 20 plus 18 plus 16. Right, so that's how you can turn something that looks graphical with all these bits and pieces, and you can do that to actually calculate your rough area using the trapezoidal rule. So hopefully that makes sense. Probably a bit of a long one, but I hope you enjoy. Be good in class, and I'll catch you guys later. Alrighty, bye-bye.